Hello, VOD people. Okay, we're continuing our explorations with F Sharp, trying to build a equipment reservation slash manager program with F Sharp, applying the principles written by Scott Lashin in his book Domain Modeling Made Functional. So I'm trying to learn F Sharp while also trying to do like domain modeling or domain driven design rather. Which yeah, I'm not too familiar with it. I kind of know the concepts, I guess, but I haven't really done it that much. So yeah, let's give it a try. So we've got some functions written, we've got some types written. It's all kind of a helter-kelter because I haven't used much of a strategy here. But I've read up a bit on the book since the last stream, and there are some things that I want to change. So let's close out this, and we'll keep this up, I guess. Here we go. So let's. I think we can remove this. Okay, that's going to complain about something. Why is it complaining over here? This expression was expected to have a type, but the bool ref, but here has type bool. Dereference a cell. Maybe it's. Is that the thing? And if that's the case, yeah, we can probably simplify. Replace lambda with not. Yeah. Right. Learning the F sharp. There you go. Okay, so the other thing that I picked up from the book since last time, I did read a bit on in the source code that came with the book, and he doesn't define the these what are they called, these types inside of the module with the same name. He actually defines them outside of the module. Oh, that's well, yeah, sure. Let's do this like so. So they're a bit easier to use. So you don't have this double thing going all the time where you go string 200 dot string 200, which makes sense. It kind of annoyed me, but I didn't really know how to do how to do it any other way. So that's what I ended up doing. Let's see. I also see that he's put these types here in their own file, which I kind of like. He calls them simple types because they're kind of like they're almost like complex types, but they're really simple. So it's to differentiate them from primitive types, which are like just like a regular string. So this is a special kind of string. So it's not a primitive type per se, but it's a bit more complex or complex than that. So it's a simple type. Anyway, let's see. We've got this, and we got phone number, right? Let's move that up too. Let's just put these at the top here, I think. Like so. Then we're gonna go take string 1000. Move that up here. Let's move it just below here. Actually, take these two. Let's just put that here, I think. And let's see, we have start date. There we go. And end date. Let's grab those two and put them below here. Same for this. Let's just grab that and put it here. Yep. Then let's do the same for end date. Like so. Yep. That should create a lot of errors. Let's just clean those up. Pretty easily cleaned up, actually. Now they're a bits easier to use. Like so. Then we're going to create a new file. Okay, why is it not creating files? Oh, there we go. I don't know why Writer is a bit slow for me. Yeah. Simple types. Let's do that. And how does he define these? He doesn't put them in a module. Interesting. So in this example, he doesn't put them in a module. I think I'm going to just copy that, but we're going to move this up a bit. Yes. Because see, F# cares about that stuff. So let's not put it in the module like this. And let's see. Okay. So it puts everything in a namespace rather. I haven't really looked into the difference between a module and a namespace in F#. But it looks like he's putting everything inside of the same namespace. No. This is interesting. Okay. This is everything in place order. Order taken, not common. Okay. Okay, so it looks like he's using namespaces to put multiple files which are related into the same namespace. I can't really say I can see why he does that. I haven't really read up on it either. Well, it looks like we can't use the open keyword at the top here. Files in libraries or multiple file applications must begin with a namespace or module declaration, e.g. some namespace dot sub namespace, right? What that's for types. Okay, simple types. Not really sure. Let's just go with namespace EQ MGR common, I guess. Does that resolve this? No. Files and libraries are multiple files, blah, blah, blah. Only the last source file application may omit such a declaration. Okay. So types also needs to be in some sort of namespace. I don't know, namespace. Yeah. You know what? We're just going to put everything into one namespace. I'll probably come back to this and fix this up later when I figure out how to properly use them in F#. I have pretty. I have like a principle when it comes to namespacing in C# code, which I do know pretty well, but I don't really have that for F# code yet, mostly because I haven't written much of it. Yeah, we need to open system. So that brings those in. I think this should be, yeah, those are redundant, I guess. Yeah. What the string M00? What the? Oh, this is okay. Here we go. Oh, there we go. Yep. Yeah, and this is actually, let's rather do string this maybe. Nope, that's not good. null or empty. Username. Oh, no. Let's see. I did see him do this. Oh, uppercase S. There we go. Let's see. Let's do the same for this. Yeah, empty is what we want. No. String 1. Oh, come on. 1000. Yeah, why is this still called username? We changed the name of that, I think. Okay. String 200. No. Are we being silly? There we go. Yes, okay. So let's head back to types. Is there anything we need to resolve here now? No. Okay. So we got simple types over here. We've got, apparently we don't need to open. It makes sense. We don't have to open anything for the simple types to be available. I guess it's because they're in the same namespace. So that's good. I'm just gonna commit this off screen. Move to own file. Move simple type definitions out from the modules. Same name. There we go. Okay. So the next thing we're going to do is the different processes or actions of the system are modeled as functions, where you basically have like a function named the action that you want to do, or name of the process, and that function is created by combining other functions inside of it. So I think the next step would be to try to model one of these. This is not the way or the order that Scott Lashin does it in the book, but I think this makes more sense for me at this point. This is a really small project. I just want to get started trying to make things work. So yeah, let's try to do some functions. Okay, so so I've got some functions already, which are processes or like actions that I kind of imagined that I would need. So and I put a lot of like sample data inside of them. I don't really think that I need this. So what I'm going to do actually is basically start all over. Actually, one other thing. We should have a way to get at the value of these. So in the book, he suggests a function named value, which takes the let's see, I'm just going to double check the yeah, it destructures. That's the way. That's what I thought. Yeah. So it takes yeah, just like this, and then it just returns the value, doesn't it? Yeah. Oh, we can actually put this just in the same line. That makes sense. Yeah, so it unwraps the string 200 to get at the value, because this is private inside of here, so you can't just get directly at it. You need to to extract it somehow. So that probably means that we shouldn't keep this in the same namespace. So let's just use common, maybe. Yeah, sure. Let's do common. Okay. Then we're going to do this for all the values, basically. So let value, and this is going to be a string, 1000 value, just return the value. This is going to be let value of phone number value equals value. Let value start date value equals value. Let's just, let's bring this whole thing down here. And I think that's it. Yeah. Okay. So another thing that I thought of is we should probably validate this end date thing, because if we wanted to represent a date of some kind that was not a start date or an end date, so these kind of belong together, it kind of makes sense, right? So the only way that you should be able to create an end date is to verify that it's before the start date. So if we were super rigid about this, maybe you should only be able to create them together, which is what I'm thinking right now. No, we're going to validate when later. Yeah. But I think that this should probably validate whether or not it's after the start date. I kind of feel like that belongs here. So we're going to do that. So we're going to put this before here. Start date of type start date. Why before and not after? Basically because in theory we could when modeling functions or when sorting the parameters of functions in F#, you should put like the most variable and most important value parameter at the end, right? So for the create function of end date, the most variable or most important value is the end date itself, the value that we're creating. So for example, if we were to apply partial application to this create function, we would still be interested in passing in the end date, because that's the important value. But we might create like a partially applied function where the start date is the same for a lot of calls after one another, to simplify the calls, for example. Anyway, in that case, we're gonna check if we need to return an error. So if end date, the variable is less than start date, then we'll return error saying end date must be the same as or after start date. And if not that, turn this. That's the start date, right? Yeah. So we need to get the value of this. So we could probably just destructure it because we're inside of the same thing, but that I kind of feel like that's not how you do it. So let's do this. This. I think we actually need to put this in a parentheses like this. Right, this should be start date dot. Can I actually remove the... No, it doesn't say it's redundant. Okay, it's probably required. That gives us the date, the value of the start date. We could, as I said, we could probably destructure this right here because we're inside of the same namespace and we can see the private thing. While that would be, again, I don't know, simpler, I feel like this is the right way to do it. It kind of respects the boundaries a bit more, I think. Anyway. Yep. So that's that. Should probably go through and add value for destructuring and yeah, sure. Okay, back to functions. So my thinking is, should this be in a namespace rather than a module then? I'm not really sure. Let's do that. Namespace. And let's do EQ, MGR, domain? I don't know. Well, let's do equipment because we're going to mix some stuff for equipment now. Okay. So my thinking is we need to model some of the processes or actions that we want to do in our system. And to figure out which one to start with, I figure I'm just gonna start at one end and work my way towards the other end. So I think I'm gonna do like add an equipment to the system first, which contains some validation stuff, and then it produces like an event at the end, which says I've created some new equipment, which needs to be stored or whatever you want to do with it. So in the final thing, there will be like a handler handling the event, which will probably persist it to some kind of database. For this example, though, we're just going to create the event and leave it at that. And the persistence part is going to be handled by some other system and not this core domain logic module or project or whatever. Something. New words and terminologies in F#. So I'm kind of trying to sort it out in my head. Also, I haven't gotten to the part about persistence yet in the book. So I don't really remember what he says about persistence. I think I have an idea what he says, but I'm just going to leave that for later because it's not really important for the domain logic. And also, if I wanted to write tests, this is what I would test, not necessarily the persistence part of the process. You might want to test that in an integration test or like an end-to-end test, but for just the really important stuff, which is the domain logic, which is supposed to make sure that everything works as it should. Oh, hello. My other computer just woke up. Let's see. Just gonna shut that down. Yep. No need to have that humming in the background. Where was I? Yeah, something persistence. Okay, so the first process that we're gonna model is probably adding some new equipment. So to add new equipment, we need a function, which create new equipment. And we're just going to return a unit for now. Oh, it's probably called unit like this. Yeah, no. Is it not called a unit like this? Oh, it doesn't see that it's a function. Well, that makes sense. It takes something and it returns nothing. Why won't you? Namespaces cannot contain bindings. What? Why? Okay. I'm not really sure what that means, but I'm going to do this instead. Sorry about that. Something we're itching. Okay. We're going to need some types for this. Should I define the types with the other types maybe? I'm going to have a look in the source code for the book. Okay. So he separated everything into 3 files, basically. Oh, sorry, 2 files. No, more files than that. Well, he's basically only modeling one process. So, okay, so I got the public types. This file contains the definitions of public types exposed at the boundary of the bounded context, related to the place order workflow. Right. So there's one file just for the types. That makes sense, at least in my head. Then we got the implementation file. This file contains the final implementation for the place order workflow. This represents the code in chapter 10, working with errors. There are 2 parts. The first section contains the type-only definitions for each step. Right. He mentions this in the book. The second section contains the implementations for each step and the implementation of the overall workflow. Right. So in the book, he suggests defining types for all the functions, which makes it easier to ensure that you're implementing the functions correctly, which I'm kind of leaning towards, I think. Part of the allure of F# is the clever compiler managing to infer a lot of the types for you, but feels like kind of a nice safety net to kind of think ahead and say, well, this function should really transform like this. And it then helps me actually ensure that it transforms correctly. Now we're transforming this way, rather. Right. Oh, there's something up my nose that's itching, and it's really annoying. Okay, then there's a third file, DTO. This file contains logic for working with data transfer object, DTOs. This represents the code in chapter 11. Each type of DTO is defined using primitive serializable types, and then there are to-domain and from-domain functions defined for each DTO. So for example, these are some helper things. Customer info DTO, okay. Then we got simple types for that, yeah. Then we got a module internal customer info DTO, okay. Functions for converting between DTO and corresponding domain object. Module internal, okay. That probably means what I think it means. It's a module which is internally visible, which means inside of the project. So, yeah, that makes sense. Yes. So if you want to go, yeah, because you want to translate from like the to and from the DTOs at the boundary of the context. Blah 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 blah. To customer info, from customer info. Yeah, okay. Then you go from, right? Convert the DTO into a customer info object used when importing from the outside world into the domain, e.g. when loading from a database. Then there's from customer info. Convert the customer info object into the corresponding DTO used when exporting from the domain to the outside world. Convert the DTO into an unvalidated customer info object. This always succeeds because there is no validation. Used when importing an order from the outside world into the domain. An order form. Okay. Okay, so you can create like, okay, so the customer info DTO can be used to create an unvalidated customer info and a regular customer info. Right. Okay, right. So sometimes you want to go from the DTO to an unvalidated instance of that DTO, or rather the main type corresponding to that DTO, because you're still not. Why would you want to do that though? Right, because you're going to try to create it. Right. Okay, I think it makes sense. So when you're loading it from an untrusted source, basically the user or the API or whatever, the external part, you're going to do to unvalidated because there is no validation. And then you're probably going to go. No, you wouldn't go from unvalidated customer info, would you? Well, it looks like. It looks like. Combine the components to create. Yep. Okay. So I don't. It looks like you're using two different things. Based on where you're loading it from. I'm guessing that in going from like the DTO to the unvalidated one, and then passing the unvalidated in through the validation system, you're probably going to get some more explanatory validation messages, I'm guessing, than going from the DTO directly to the validated one. Because you will get the validation still. I'm looking at the code and it still validates because it's using the create functions, which will validate all the inputs. But I'm guessing that they're going to be a bit more opaque when you don't get in like a collection of all the different validation errors. So it's not going to be as useful. But if you're loading from a trusted source, that's probably going to be like a shortcut. So that makes sense. I was actually kind of wondering about this. So I think this kind of explains it for me. I'll just have to check, basically. Anyway, let's try to make this for ourselves. So what he's done in his thing is have like a file for the public types, which are visible from the outside. Does he have any private stuff in here at all? Let's see. Private. No, he does not. Okay, let's see. This thing is actually a bit off screen. There we go. So he's only got the public types, as he calls it, which are all the unvalidated. And then we got the outputs and the inputs. Okay. Okay, right. Because you got the common types inside of this domain or this bounded context. That makes sense. Okay. It's all coming together now. Right. I think we're actually going to just follow his example on how he structures everything because it's going to make things simpler, I think. So let's see. He puts that in its own thing. And then, okay. Yes. And that's just might be just one part of it, right? Yeah. Okay. Let's see. Okay, we got EQ Manager Common because this is called. This would probably be called Core then, shouldn't it? Because yeah. Okay. So this project, in his example, in Scott Lashin's book example, he's named the project after the bounded context, which makes sense. So he calls this order taking, then there's like a place order, which is a part of the order taking process. Right. Are we going to do the same? I wonder. Thinking about it. Oh, I think so. So I'm kind of debating whether or not this should just be like equipment management, maybe? Yeah, I think so. Can I rename this? Uh, tools? No, that doesn't seem right. No, I think it's this. Rename. There we go. Okay, so it's possible. Right, so let's call this equipment management. Rename, blah, blah, blah. Renaming comments. Okay, sure. This is gonna think for. Okay, it's basically copying everything over, it looks like. Okay. Then we're gonna call this specific file. We're gonna call this common.simpletypes. This is gonna be inside of the namespace called equipment management. The common. And this is also going to be called common. So yeah, right. Let's do one thing at a time here. Let's do this. And this is also going to be namespaced into common, I think. Equipment management common. Yeah. So, okay. So types, they call it compound types actually in this thing. I'm actually going to copy that too. Which symbolizes that these compound types are a combination of simple types, basically. So we have the simple types, then we've got the compound types, which are the complex types inside of here. And we're not going to worry about user for the time being. So the rest of this file actually models the stuff that we want to model. So we're going to also, yeah, let's just leave reservation here for now. But that doesn't, we're not getting to that until later, basically. Let's see here. I think okay, sorry about that. Right, because we had a server. Yeah, this is probably just going to be like a come on, user ID. I think. Should that be something complex? Yeah, it's gonna have to be. Yeah, so we're gonna go back to simple types. We're gonna create like a user ID. I think. So let's go up here. Let's make some space. User ID, which is a private user ID of string. I think. Maybe it should be a quid. Are we gonna assume that's quid? Yeah, we're gonna do that. Yeah, quid. And then we're gonna create a module called user ID. It's gonna have a value thing where you can go user ID value and then what do I do? And extract the value like so. Oh, here we go. And then we're gonna have a create one, which is gonna take a string, I think. Yeah. User ID, right? Then we are, let's see, we're gonna use the grid.parse, I think it's called. Yeah, then we got two alternatives, parse and parse exact. Parse exact converts the character span represent blah, 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 blah of a grid, equivalent blah, blah, provided the string is in the specified format. Converts the string representation of a grid, okay. Oh, right, you provide the format too. Okay, we don't want that. So this parse is gonna blow up on us if it fails. The other alternative is try parse. Ooh, actually, there might be. Isn't there like a wrapper for try? Ooh, that's not what we want. For like try parse. Oh, it might be just for the right. It might just be for the primitive types, like int and stuff. I think there is like a wrapper or like a custom handler for try parse in F sharp, which is a bit more functionally, yeah, better. Okay, we're gonna. I think it's like this. So we're gonna try to parse. Let parsed be GUID parse. Parse and then the user ID, like so. And we're gonna okay with a parsed over here. Yeah. Nope. It's gonna be a user ID parsed, like so. Right? I think so. Yeah. Oh, it's probably yeah. I think it's with, and then you do like this, I think. And we're just gonna catch exception. I think this is possible. I'm not really sure what I'm doing here. And if it does that, we're gonna do error. User ID must be a valid GUID, I guess. I guess that's what you do. Is it the other way around, maybe? Man, I have to look this up. Let's try searching with. Oh, let's just try searching with try. Oh, right. Oh, if we try to search for this, maybe. Nope. Is it this? Nope. Like an arrow pointing. Like so. No? Okay. That's not very helpful. Okay. We're right. We're due some error handling in one of the later chapters. So if we go here, implementing, and the first thing that we do is not handling the errors. Right. Implementation, working with errors. Domain errors. We're gonna at some point here. Okay, right, here we go. Yes, we do a try, then we do a with, and then it's the other way around for starters. Oh, here we go. That helped. Okay, what's it complaining about here? The type test or downcast will always hold. That is kind of the thought here. What's it complaining about here? A unique overload for method parse could not be determined based on the information prior to this, blah, blah, blah. Yeah, okay, so it doesn't know if it's a string or if it's a read-only span of characters, which is fine. That makes sense. So we're just going to explicitly say that it's a string here, which is going to help that. This is going to complain because it always holds. Does this say what kind of error? Argument null exception. Okay, that's not going to be a problem. Format exception. Input is not. Okay, so we're going to do a format exception here. which is very more specific and actually what we want to catch. Right. So that is that. Let's head back to compound types. This is a user ID. Okay, this works now. Okay. That is good. That is good. Right. The question becomes, should we have a user representation here, or is that not necessary? We don't know yet. We're just gonna no. We're just gonna leave it like this for now. With the intention that we're gonna get back to this later in some form. Let's see. Back to functions. Right. This is going to be in a different namespace now. This is going to be equipment management dot something. Let's have a look at the okay, yeah. So this is going to be let's call it something different first. So this is going to be a specific action within this domain. Okay, this is starting to make sense now, I think. So this is going to be specifically, this is going to be add equipment. Yes. Add equipment. Equipment. And it's going to be the polytypes of add equipment. Right. So this is going to be add horrible word. Add equipment, like so. Okay, yeah. So this is specifically, this is generally for everything, right? Yes. And this is going to be specific for the add equipment part. Okay, that makes sense. I think that makes sense. So the first thing we're going to do, we're going to define a type, which is called unvalidated equipment. And the unvalidated equipment is going to be consisting only of simple types. So no, not simple types, primitive types. So let's bring up the equipment in the compound types over here. Let's bring these up side by side, I think. Oh no, Ryder, you're so slow. Why are you so slow? I don't get it. Anyway, there we go. Okay, so here we've got the proper equipment, the one that's been validated and everything is working as it should. And this is the unvalidated one. Dun dun dun. This is going to be exposed to the boundary. So this is going to, have I typed equipment? Yep. There we go. So this is going to be exposed to boundary. So it's not going to have an ID. It might not even, we'll circle back to it. If it should have an ID in the internal representation. I think it should. Yes. Because this is an entity, I think it's called, which is basically this thing is distinct from all the others of the same type. So this equipment instance or this data structure in equipment is different from all the other data structures, which are also of type equipment. Hence, it has an ID, which is unique to this one because they're not interchangeable. So even if they look the same, like they have the same name, the same details, whatever, they are not actually the same. I think they call it entities, and they are signified by being unique among their peers, basically. So it's going to have a name. It's going to be a string. Some details. It's going to be a string. It's going to have a rate, which is going to be an int, because it's specified in øre, the uh, what's it called? I don't even know this word in Norwegian. So the lowest denominator in the Norwegian monetary system, I guess. Rate start. Yeah, rate start. Blah, blah, blah. Stop. Wait, try it again. Start day. And I'm a bit uncertain. Maybe it should just be like an int, maybe. So you specify 1 or 2, and then it gets translated internally. Yeah, I think that makes sense. And rent duration limit. Yes. Nope. Not the type. We're going to have a property of the same name, though. Rent duration limit is going to be ... int. Right. Okay. That was easy. The next thing that we're going to do is I kind of want to... No. That's going to be in the implementation. Right. So in the book, Domain Modeling Made Functional, Scott regularly puts like simple things together in smaller types. Oh, sorry. All the time. So maybe like these three would be like a common thing. So this would probably be like equipment info for the first 2 lines, right? Because it's just information about the thing. And these 3 would probably be something like reservation info or reservation detail or rent info, because these belong together in that kind of thing. I might want to do that. Nah, I'm going to keep it like this for now. Yeah, I think so. So I think that's the end of the simple types for now, or the public types for now. So the next thing that we're going to do is we're going to go, we're going to create a new file actually. And we're going to name that add equipment dot implementation. Like so. This is going to be a namespace. And it's not going to be any core. Apparently, it's not quite updated yet. Yeah, just leave like that. And then we're going to do this. And we're going to find this. And I think we're going to do this. No. We're going to do equipment manager dot add equipment. Yeah. No, not manager. Management. Yeah. So those are going to be the same. I think, yeah, that's right. Right. So the first thing we're going to do, we're going to just define the function. Right. Actually, in public types, is the implementation thing? The file contains the first two parts. The first section contains the type only definitions for each step. Right. So it validates everything. Okay. Should there be... So it defines like a validated version of everything, which is distinct from like the common implementation of everything, I think. So let's see. He has like a validated order line in the example here. And if we have a look at his public types, Okay. How about the compound types? Are there like... No. Okay. Yeah, see, the compound types are really few. There's really not a lot of them. That kind of makes sense, I think. Yeah, so I think actually I want to make like okay, so let's say what are the steps that I want to do here? Um, yeah, because he does some complex logic regarding like an address. He checks it with an external source whether or not the address is valid. Um, he validates the order line because that's kind of complicated too. I think this is mostly like internal logic. So we probably should be fine here. I'm just kind of debating. Okay, let's say that we have like a validated equipment, right? It has a name, which is a string 50. Nope, 200. And for this, we need to open the, common things. Open, what do we open? Equipmentmanagement.common. Yeah. That's going to be a string 200. We got details, which is a string 1000. We've got a rate, which is a rate. We've got, isn't that what it's called? Okay, let's get back to rate. Oh, it's probably in the compounds. No, wait, that doesn't make any sense. Shouldn't be in here, should it? Oh, it's still, wait, where is it? Oh, we didn't move it. Right. Okay. Let's move this to simple types. Let's do that over here, like so. Then I'm going to move this up here, just below phone number. That's not what I want to do. This is what I want to do. Yep. And the rate, yep. Less than 0. If not, it's going to be fine. Right. So if I now go back here, yeah. Rate start day, which is going to be a rate start day, and then a rent duration limit of rent duration limit. Why is that not properly? Because it's right here where it should not be. Simple types, like so. Move this up here, like so. All right, let's go back. Let's go right here. There we go. Same for this. Okay. Well, this should probably be... okay, let's move this up here too. That's going to be... It's going to be here, I think. Right. Oh, that's not what I meant to do. Yeah, we got a piece of equipment, and then the reservation. And the reservation is kind of superfluous at the moment. So we got a piece of validated equipment, right? I think that makes sense. And then we're going to define the type that defines it. So validate. Right, so we're going to do validate equipment. Yes. And that's... Is it going to check anything externally? No, not really. So it's just gonna receive like an unvalidated equipment, and then it's gonna output a result, which is either a validated equipment yes, or a validation error. I think, yeah. Wait a second, where does he define validation error? In simple types? No, that can make sense. That doesn't make sense. Probably here in the public types, right? No. Where does he define validation error? That's in the chapters part. Let's go further down. Okay, puts it inside of the validation, actually. Right here. Validation error. Does it become like a compound thing later, maybe? A lot of these. Let's see. Validation error equals. No. No, there is like another validation error. Okay. Let's see. Place order public types. Okay, yeah. It is in the... Oh, right. Okay. Yeah, so it's in the different thing. Oh, okay. There's like the evolved version of the whole project where everything is a bit better. Oh, I should have been looking at that all the time. Oh, right, because here there are some internal types too, which... Oh, they're all placed inside of an module internal. Right. This file is a bit shorter now. So there are the invalidated ones. And then... Yep. Yerp derp. Then there is the internal types, which contain all of the validation logic. Define each step in the place order workflow using internal types, not exposed outside the bounded context. Right, this makes sense. Yes, okay. Then there's the pricing, which move all pricing logic into its own module. It's going to get complicated. Place order Implementation. This icon has implementation to has type one definition for each step. It really doesn't though. Because it starts with section 2. Right, okay, yes, he's copied the text, but it didn't update it correctly. Okay. So the first part that I made here, these are supposed to be internal types. Okay, that makes sense. So we don't want to expose all this. Well, the validated equipment. Do we not want to expose that? No. Or no? We got the unvalidated stuff. Yeah, and then we got like the... Where does a priced order come from? Then we've got the public stuff, which are the final events, which base themselves off of... Okay, so we're just going to do it inside of this. And then we're going to go priced order. Equals. Okay, yeah. Okay, so that's inside of the internal types. Okay. Priced order. That's going to be inside of the internal of the place order. Let's see. Okay. That's defined. Wait a second. How is that possible? That shouldn't be possible, should it? Because this is defined in here. Yes. That doesn't make sense. That's the other way around from what it should be. Okay, we're gonna we're gonna leave that by the side for now. Okay, but the internal types basically contain all these different types for validation and whatever. Yeah. We're gonna make this uppercase because this is a type, and this is not going to be like a public thing. No, right? So he's putting some stuff, or is nothing in that? Nope, it's in a namespace still. So everything internal is apparently inside a... Nope, that's internal too. And so is that. Okay. And this is public. Not everything though. Some of it's hidden. Okay, I should probably read more of the book to figure out all this all out. But yeah, okay. So the public things are exposed via namespaces, but the internal stuff is put in internal modules. Not really sure why one above the other, but I think I remember that being something that he mentions in the book. Okay, so that's going to be an internal thing. That makes sense. So this is going to be internal. That makes sense too. And then this is just in the open. Okay, so we got the public types, right? Yeah. So this is going to be in the open. Yeah. Are we also going to define the... Yeah, we're going to define the events too. So we're going to have a type called equipment. I'm not sure if we should call it add more, or if we should call it create. It kind of feels like, no, you know what it is? It's register. That's the word we're looking for. Yeah. Register. So we're going to change that. Ooh, this is going to change a lot of things. So this is also going to be register equipment. And this file is also going to be renamed register. This is also going to be differently register. Okay. So this is, and this is going to be the implementation, which is going to be private. So we're actually going to put this in a module internal called that word, I'm not going to be able to write it correctly. There we go. Equipment management dot register equipment dot internal. And that's going to complain because namespace or module something. Yeah, but it is now. What are you complaining about? Oh, it's not. It's the last file, so it probably should be omitted then. It should be. No, it doesn't look like I have to. Why is it complaining about this then? Who knows? Oh, come on. Files and libraries, blah, 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 blah. Only the last source file of an application may omit this. How is this not okay, whatever. I'm not going to bother with you being a silly banana. And this is going to be called instead inter, oh my God, types. Okay. There we go. Not really sure why it's complaining still, but whatever. Okay, register equipment. This is going to be in the set of public types. That's just going to be in the, yeah, that's going to be here. And then, yeah, so those are going to be named after that. Yep. This all makes sense now. Right, so in the internal types, we got the validated equipment. We got the definition of the validate equipment thing, which will create the validate equipment. And then as the last thing that we do, we're going to create the event. So I'm guessing that we need like a create event thing defined. Let's just have a look. Type create events. Yeah. So type create events. That's just going to be, we need a piece of validated equipment. Validated equipment. Oh, sorry. No, equipment. Wow. We need a piece of validated equipment, and then we're gonna produce a we're gonna equipment registered, like so. Yeah, that's what we're gonna produce. And for registered, like so, that's going to be basically validated equipment. This is where it's going to get really... Oh, that actually worked? Wait, I don't understand anything. I thought they had to be in order. Okay, whatever. Yeah. Well, it's not going to have an ID. Usually, I would create that in the database, but interesting. How do we do that? Because the validated equipment should really have a unique ID. That's part of the... I think that we're going to add this in here, actually. Let's call it an equipment ID. And then we're going to go to simple types and define that. Type equipment ID, private equipment ID of GUID. Module equipment ID, let value. Wow. And ID value. So when creating equipment ID, do we need any input? No, we do not. How do we define that? Just like this? Like this? Oh, that's the name of the thing. This is how you create a unit. Yeah. This is basically always going to work. New ID, new width. Like so. And then we're just going to... This is complaining. So the argument should be separated. Okay, yeah, you need to do this, I guess. Yeah. Okay. Let's see. Why is this complaining? Unexpected symbol in type definition. Expected. Okay. Why does it work down here, but not up here? Wow, I've even written it wrong here. Wow. How do I manage to do that? Does it not understand that we're talking of a function here, maybe? Why is it complaining? Unexpected symbol, arrow, in type definition. Expected, a bar or other token. Why though? Why? Okay, now it works. Oh, is it because it's just a single line, maybe? Whoa! Well, that would create a lot of different errors. Okay. It's an unvalidated equipment. Oh, crap. Have I typed wrong again? Let's see. Unvalidated equipment. Wow. No. An unvalidated equipment. Oh, right. We need to. Do we need to? Should it? Yeah, but should it need to? This only opens the common part. Okay, so internal types, right? Validate order. Unvalidated order. Where does that come from? Doesn't that come from here? No. Where does that come from? From compound types? No. Wait, what? Unvalidated order. Let's define the public types. as is this. Yes. So we're doing the same. Is it inside of a different module, maybe? We are defining types and submodules, so we can use a namespace rather than a module at the top level. Okay, maybe we can have modules inside of modules. Does that make sense? I don't think so. Huh, okay, whatever. Or taking the plate's order. But this is not inside. Does it open anything else later on? No, it's just the one. Huh, I wonder how that works. I don't know. Why do they not have to? Okay, whatever. Okay, let's see. Where? Wow. I am unable to type that name correctly. Validation error. Okay, that at least that's correct. Where did I figure out where this was defined? Validation error. Yeah, that's just in public types. Okay, right. Let's do that. Type validation error, which is invalidation error of string. This should probably be something more complex at a later point, but we're gonna go with this for now. Okay, right. So now everything's working again. I'm kind of, and I think I understand why I'm doing the different things that I'm doing. I like the structure actually, but because it really defines very explicitly which parts belong where and which are supposed to be visible and not. Okay, we've got validated equipment, which is after it's been validated. Then there's equipment registered, which is what happens after it's been validated, right? So we got validate. It takes a unvalidated equipment and generates either a validated equipment or validation error. Then we need to create events, which takes the validated equipment and emits the equipment registered. Right. This makes sense. Wow. Not wow as in holy crap, how does that even make sense? But rather, I actually understand what I'm doing. This is actually fun. Okay, next one. Register equipment dot implementation. And this is also going to be a module, correct? None of this. I'm just going to type everything from scratch. So this is going to be equipment management dot register equipment dot implementation. This is also going to be internal because no one is going to actually see this. So this is going to be the implementations of the stuff that we put in internal types, basically. So you see in his example, it contains a lot of different helper functions and stuff. Yep, convert everything into that. Yep. So he's using like a computation expression, which is a F# thing, which is kind of cool, but I'm not going to be using that for now, I think. So what I'm going to do instead... How am I... How am I gonna put this together? If not using the result thing that he's doing. Oh, okay, rather, Is there something called result already? No. So whenever we create one of these thing, okay, so it goes through and tries to create all these different things. Then at some point it creates, yeah, validate order. So it takes everything, then it tries to create everything. Okay, that makes sense. I understand what he's doing at all points, but yeah, okay, let's see. Let's try to do this. Validate equipment. Yeah, because the last thing in this file is probably going to be the place order thing. Yeah. Yeah. So that's actually something that's missing from our internal types definition. So if we go back here, we should have, or should that be a public type maybe? No, that doesn't make any sense, does it? No, wait. Yeah, it is a public type. Yeah, it's the last thing defined in public types. It's the flow itself. Right, so you got to type like register equipment, like so. Which is defined as an unvalidated equipment resulting in the result, which is either equipment registered, equipment registered, or register register equipment error. Yes. And I think that this should probably be also a register equipment error. It's probably going to be more stuff later, but for now it's just going to be the validation of validation error. Right? Yes. Okay, that makes sense. So you're gonna get it. Yeah. Yeah. Okay. So that's. I'm just a bit confused. Where do we actually expose this function though? Because this is in an internal module, is it not? Oh, right, but it's actually exposing everything in this API file. Let's have a look at that one. What does it say? This file contains the complete workflow exposed as a JSON API. 1. The HTTP request is turned into a DTO, which is then turned into a domain object. The main workflow function is called. The output is turned into a DTO, which is turned into a HTTP response. Right, so in this thing, it is exposing the whole thing to the public, basically. Which makes sense. It says the HTTP request. Yeah, okay. So it defines a very simplified HTTP request. And a response, right? I don't think... Okay, so it's doing a lot of... Yeah, this makes sense. Okay, yeah. This is probably defined in public because these are public dependencies that it needs. Okay, so my thought is that the HTTP API, which is going to be present at some point, is going to be in a separate project, which means that I need to kind of define where do I expose the implementation. Because I think that the deserialization and deserialization usually happens outside of the bounded context, which is, I think that the outermost, or rather the only publicly exposed thing from this project should be the unvalidated equipment and whatever is in the public types stuff. So everything converting that from to and from JSON and whatever should probably be in the API thing. I think that's correct. It feels correct. Okay. But that begs the question, when do we expose the workflow itself? Do we don't do that in the public types? Do we specify like a or register equipment API thing that kind of exposes this? We might actually. Okay, let's table that for now, and we'll get back to it when it's actually required. Why are these two? Oh, man, I actually managed to type it wrong again. Didn't even notice until now. Equipment. There we go. Now the file should be correctly named. Yes, okay. Is this still complaining about the modules thing? No, now it's fine. I have no idea why that is happening. Okay, whatever. Okay, so let validate equipment. No. Yes. Yes, validate equipment. Boom. It takes... yeah, it's supposed to be... it's of type validate equipment. And then we do this. It's fun. It takes an unvalidated equipment, and then does something to it. And I'm wondering how to do this without result thing. I think he kind of does something similar in the book. Okay, if I search for result and a curly brace, no hits. Okay, that's so weird. Okay. Result. Okay, so before this, let's have a look. before, well, actually, let me see if there is an implementation of this. No, even this one without effects, maybe. Does that not use results? The result computational thingy? It looks like it. Yeah. Okay. Let's see. Let's have a look. To address. How is that defined in here? Let to address. Okay. Do none of these actually... Oh, right. These are defined up here because they do not throw any errors, do they? Yep. Yep. It shadows everything and it just creates stuff. Okay, that makes sense. Crud. Yeah, that makes sense. That's why he's making everything work, because he doesn't use the result thingy, and I don't have that because right. Because that's not the default part of F sharp. It's kind of confusing because he redefines result, which is a defined part in F sharp 4.1 and newer, which means that I kind of have to kind of separate which parts are his and which parts are actually part of the default result thingy. So let's call F sharp result computation expression. Yep. There must be a way to do this, right? So you take the unvalidated equipment. And what I actually want to do is I want to create like I want to create validated equipment for this from this. So if we put this over here, have a look at the validated equipment. So we need a equipment ID, right? So let's just call it ID. And this is easy. We just do equipment ID dot, oh, not create. And that creates it for us. So that's easy. Yeah. Then we need a name. So let's call that equipment ID. Nope. What am I doing? The name is going to be a string 200. I'm going to create using the unvalidated equipment dot name. No, not that one. The unvalidated. Wow, I can't really type for equipment. These are supposed to be the same thing. Unvalidated equipment. Should there be anything more here? Am I... Yep. No, this should be it, yeah. Why is it not? Okay, let's just... let's just return equipment. Okay, this okay. Why is it complaining? Let is missing expression. Yeah, sure. Unvalidated equipment dot name. Wow, this is really not helping me at all. Why is it complaining now? Function takes too many arguments or is used in a context where a function is not expected. Okay, that is actually more helpful. Nope, not that one. Oh, right. I see the problem here. This is supposed to be validate. There we go. Okay, that is better. Right, okay. Sure, let's do this instead. Fighting the type system. Yay. Okay, let's see. Create unvalidated that one dot name, which is a string, which is what this says. There we go. Yeah. Okay, so now the problem actually is this might be this is a result. And I don't think we can do like early returns here. So if name, can we do like a result is error? No. So we can do like a result map error, which lets us just say about validation. Right. Yeah, so map the error to a validation error, which then makes this, yeah, a string 200 or a validation error, right? Because what I would want to do then is actually go like if name, if name is error, is like error, then return something, return like the error, return name, but that doesn't work because you can do early returns in F#, which is why you need the other thing. So what we're going to do instead is that we're going to define a cheat. So let unwrap. This is something we made last time too, yeah. And we are going to call this result, and then match result with, and if it's okay, value, then return the value. If it is error, that's what we want. Error, with the message, we're gonna fail with the message. So what that's gonna do for us is let us it's gonna let us say unwrap at the end here. And that's gonna complain, but this is gonna be an object. Okay, let's see. Why is it complaining? Expecting a result, but was giving something else. Does not match the type string. Right. Let's call this fail validation. Fail if invalid. And this is going to be a validation error with a message inside. Right, and this is not going to... The expression is expected to have a string, but as here type... Here has type validation error, right. Yeah, we're going to do this the other way. So if we do this, this, oh, stop, this, and fail with. Does that work? No. What's it complaining about now? Oh, maybe if I do validation error message and then do fail with message. Does that work? Yes. And then we do fail if invalid. There we go. That works. Nice. So now this is not what we actually want. It doesn't really return a validation error if something fails. I'm gonna have a look at the result computation expression that Scott Blashen makes in his in the book to see if I understand computation expressions really, and give that a try. Because that seems to be the best way to do like the early returns. I can't fathom another way to do it. And I think that's mainly because I only think in early returns, basically. All right, so I probably should be able to do this some other way using functional paradigms, but I don't know them. So we're going to do this instead. This is a string 1000 create from unvalidated. Oh, come on. Validated equipment. Come on. It's a bit silly about these things sometimes. Result map error to a validation error. So the reason why I'm wrapping this. Nope. Oh, come on. Wait, what? Incomplete value of function definition. Yeah, well, so fix it for me then. Why are you being so weird? Oh, okay. That works. Let's see. Let rate be a rate dot create unvalidated equipment dot rate result map error validation error fail if invalid. Let rate start day be rate start day create. Oh, right. We didn't actually define a thing for this. Let's see, simple types. Do we make all these private, maybe? Or do we wrap this one more time? I think we just make a module with this. Yeah, rent duration. Okay. Rent duration limit, right? This, oh, right. Rate and rent duration limit doesn't actually have any value thingies. Let value be rate value equals value. The same goes for this. Let value be rent duration limit value equals value. Okay. So this is going to be a module called rent start. No. Yep. No. Rate start day. Let value be rate start. Yeah. Let create. Rate start day. And that's going to be if rate start day is less than 1. Error with, oh, wait a second. Yeah, that makes sense. Rate start day cannot be less than 1. LF rate start day is more than 2, then another error. Rate start day cannot be more than 2. If none of those, return I could actually make a pattern here saying that if it's 1 or 2, return OKs, and if it's not, return. No, we're just gonna return OK here. No, because we need to actually translate it still. Actually, we're gonna do it like this. Okay, so match rate start day with 1, in which case return an OK with rate start day of first, then 1 for 2, which is second, like so. This is probably going to complain. Incomplete pattern. For example, the value 0 might indicate a key is not covered by the patterns. Okay, so let's fail with to do. Right. Because this is what I'm wondering. I could just say rate start date must be 1 or 2. I could say this and just drop all this basically. The benefit is this gives you an indication that what's wrong, but while this kind of doesn't. This explicitly says it can't be less than 1. So okay, it's too low, and this means it's too high. But this just says it's not either 1 or 2, which means is it lower or is it higher? We don't know. Which is it doesn't really matter. We're going to do this instead. Looks more F# too. Okay, so having done that, rate start date, create, and let's just pass in on equipment the rate result map error to a validation error, then fail if invalid. Next up, Hmm. Rent, duration, limit. Rent, duration, limit, create. Ah, crap. Yeah, so if you're watching this on the Twitch stream, you're probably going to see some errors right now. Anyway, rent duration limit, create. What are we creating? This completely made me rent duration limit dot create. Unvalidated. Wow, that it just completely threw me off. Rent duration limit. Never. For the last one, we're just gonna copy these two, like so. Okay, so it looks like OBS has managed to reconnect, which means that if you're on Twitch, you just came back online, and if you're watching the VOD on Twitch, I'm not sure what just happened. And if you're watching this on YouTube, nothing has happened at all, because this is the local recording that you're watching. Okay. Yep. So we got all those things figured out. Let's create equipment. Yeah, didn't manage to write it correctly this time either. Be one of these, and it's gonna be an ID. Of ID. It's gonna be a name of name. Details called details. What's going on about here? What am I doing wrong? Is it supposed to be equals? No. It's supposed to be this. Invalid record sequence, blah, 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 should be... Yeah, no, I think this is right. Let's just continue and fix it after. That's going to be rate. Oh, nope, no, not one of those. Rate. You know, the variable is right there. Rate start day is going to be rate start day. And rent duration limit is going to be rent duration limit. And then we're going to pass back equipment, right? So let's see. Unmatched. Well, it's right down here. Let's have a look, see. Should it be like this? No, it is equals. Oh my god. Wow, really? I think I'm mixing this with Rust. Why are you? Okay, there we go. Is this right? Yeah. Well, these are not right. That's for certain. Okay. This is complaining because it doesn't know, but it has type equipment. Okay, right. Question is, if I change this to validated equipment, does it recognize it as such? I don't think so. It shouldn't. Validated equipment. Yeah, I know. Right. Validated equipment. This is now fully validated. Right. Why is it complaining about this? Oh, I didn't actually call the function. So if I do this, it should work. Yeah, there we go. Okay. Okay. That's still a Phineas and Ferb reference. So we have validated the equipment, right? Then we need create event. Oops. Sure. Create events. And this takes a validated equipment and creates a equipment registered thingy. The question then becomes, can I just do like this, do this? Validated equipment. Does that work? Well, thank you for not helping me out. The expression I have to have type equipment registered, but here has type validated equipment. Okay. They are basically the same thing. I think I explicitly define equipment registered as validated equipment. So these are the same type. And F# knows this. Yes. So when I receive validated equipment here, it knows that this is the correct return type. But is there any way to cast it? Well, actually, that begs the question. Because in Scott Wlaschin's book, he does this exact thing. So, how can I do what he does? So let's see. He has in the public types, he defines let's see, where are the events? Place order event. Ow. Is it in the internal types? What? No, that doesn't make any sense. Does it? Place order event. Place order event. Didn't I just look at this? Okay, order placed, event to send to shipping context. Order placed is the same as price order, and price order is indeed one of the priced order. Actually, if we do this, no, we do this, and do equals. No, that doesn't work. Okay. Where'd that go then? Priced order. Yes. No, wait a second. Yes. So priced order is a type, which is a data structure, right? And then it says that order placed is the same as priced order. So those two are equivalent, right? Then and then it takes order placed, Looks like he never uses it, actually. Well, that's annoying. Order ID. How do I convert? I'm not certain that there is any way to do this. That's just a conversion. Create shipping event. What? Shippable order placed. Okay. Yeah, no, it just copies everything. Yeah. Yeah. No, yep, it's just done manually. Too bad. Anyway, let's just copy these then. What do we got? ID is supposed to be validated equipment. .id. Wow, could this be any harder? Well, it would help if I actually managed to type your registration. Okay. Let's see. If we do this, yeah. Name. Details. Rate. Rate. Oh. Rate. Start day. Rent. Duration. Limit. I think those are all the different ones. ID, name, details, rate. Yep. Has to have, but it has type equipment. Oh my god, this is more equipment registered of type equipment registered, and then equipment registered. Okay. But here has type equipment. Why though? Is this defined wrong? No. I mean, you know what the type is. You know what this is supposed to be. Validated equipment, yes. And it's supposed to return An equipment registered. No, I can put this in this position. Yeah, okay. Yeah, it's not defined. Right, that makes sense. Yes. This expression was expected to have type equipment registered, but here has type equipment. Why does it think that though? Do we really need to redefine this? To the shipping context. Order placed. But it doesn't use order placed anywhere else after. Order placed. Let's do the whole solution. It's never really redefined. Order placed equals. First, it's undefined. Then it's basically called dot dot dot, which is kind of funny. Then it just changes to priced order, but it's never defined any differently. Doesn't look like it's ever actually used anywhere. Hmm. Let's see. Yeah, I can actually. There we go. It passes it just straight into the the option. So do I do like equipment? No. Do we do like validated equipment passed into equipment registered? No. Equipment registered is it's the same as validated equipment. I feel like I'm on the verge of getting it, but I'm feeling like this close. It feels like I'm supposed to equipment registered. Is that what I'm supposed to do? This expression was expected to have validated equipment to A, but has type equipment registered. Yes. How do I... How is this not just this? Was expected to have equipment registered, but here has type A to A. Yeah. Right. It's supposed to just be validated equipment. This feels like the right thing. Yes, but it complains that this expression was expected to have type equipment registered, but here has type validated equipment. And it feels like, yeah, but those are the same thing. I mean, I can redefine. I'm going to look this up. Yeah, I should probably end it soon too. Okay, let's see. F# type alias, I guess. Cast? I don't know. Okay. Okay, they behave differently and rightly so. Blah, blah, blah. Mm-hmm. Okay. Let's see. Okay. Yes. Oh man, OBS is struggling again. I think there was something wrong with the web connect the internet connection here, so it might be that. Okay. Hmm. It doesn't really explain. There's a whole like blog post on understanding F# type aliases, and it doesn't really explain it, so you don't really understand anything about. Yeah. Okay. Mm-hmm. Yeah. That's not what I want. Right. I know this. So it seems if you create a type alias, I can use them. Blah, blah, blah. Not what I wanted. Casting and conversions. Upcasting is implicit, blah blah blah, and we're slightly different. Upcasting is applied automatically when you pass arguments to methods on an object type. However, for let-bound functions in a module, upcasting is not automatic unless the parameter is declared as a flexible type. So that's something else. Blah 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 blah. Static out means that the success with the cast determine a compile time. If a cast that uses compile successfully, it's a valid cast and has no chance of failure at runtime. You can use operator performance as a conversion, blah, 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 blah. Compile attempts to infer the type you're converting to, blah, 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 blah. It performs dynamic cast, which means that the success cast is determined at runtime. A cast that uses blah, blah, blah. Okay. Okay, so I think... Yeah, it uses inheritance as an example here, I think. Yeah, but I'm gonna try that anyway. So let's see. So what I actually want here is just this thing, and then I'm gonna we do this, and then I specify equipment. Oh, come on. Equipment registered. Type constraint mismatch. The type validated is not compatible with type equipment registered. Okay. Yeah, so it seems like I'm not going to be able to do this. Maybe it's explained somewhere else in the thingy, but for now, I'm just going to have to bite the bullet and redefine this. So this instead of this. Oh. Yep. Let's do the same here. And then we should be able to do this instead and delete this. This is going to complain. Equipment, but it has a validated equipment. Wait, what? Oh, right. Whew. That's my fault. I thought I was still not figuring it out. Okay. Right. So now this is all correct. And we're able to create events, right? And then as the last thing, because what we want to do is let where do I define the public types, don't I? Yeah, register equipment. Takes unvalidated equipment and return a result of equipment registered or register equipment error. So register equipment. Equipment. It is of type register equipment. Unvalidated equipment. Freaking out. Equipment. validate equipment. And then result dot bind that to create events. Yes. And this could potentially register equipment error. Yep. So this thing right here, I think I can just do this with result map error and say that it should be a register equipment register equipment error, like so. Maybe this needs to be in its own separate thingy, maybe? Like so? Nope. Put in and validate, then return equipment registered, right? Which is what this produces. Yeah. So it's not so much bind as it is map. Yeah. That makes that one correct. Right. Bind is if this had returned and a result too. Yeah. That makes sense. Okay, so now it's just this one. Register equipment error. Why will it not let me? This returns validate equipment or a validation error. And I want to map the error to something else. But it's claiming type mismatch, expecting a validate equipment to unvalidated equipment. A validate equipment does not match the type result A or B. Okay, this makes for less errors. Register equipment error is not defined. Okay. Import missing thingy. There's just one case. Oh, right. It's supposed to be validation. Validation. Right. That makes it correct. Yeah. Okay. Yeah. That makes it right. Okay. So yeah, that's how you register equipment, basically. That took a while to implement. But again, it's the first one, so it's a lot of searching and trying to figure out how stuff is supposed to work. But I kind of like this. Yeah. I'm gonna have to try it a bit more to see if I really fall in love with it. But I like the idea of it at least, where you kind of meticulously define everything quite explicitly, really, in the type system at least. With the types, you are pretty explicit with the types, which again leads to more safer code, basically, because the types themselves, or the type system, can validate a lot of your logic for you, which is nice. So yeah, I think I like this. Next time, I'm probably gonna implement one other workflow, if not register equipment, something else, which will hopefully go a bit quicker now that I've tried my hand at one of them. And I think I kind of see where the boundaries are supposed to go between the public types and the private types and all that jazz. So that's fun. And it's also the book itself is a lot clearer to me now that I've started actually applying the principles into to some actual code. It's some of the questions that I had are suddenly actually becoming clearer on how to solve different stuff. So that's good. Because there were some things that were kind of confusing to me, but now that I've started implementing stuff, I kind of understand why some things are the way they are, basically, or why you don't focus on different specific things that I was wondering about because they're actually not relevant for this part of the code. So yeah, that makes sense. Didn't make sense to you, but made sense for me. Anyway, that's going to be it for now. It's getting late. I've been doing this for 2.5 hours with not too much code to show for it, basically. So, yeah. And we had some network problems too, so this is probably going to be really weird to watch on Twitch, but the YouTube thing should be okay because it's based on a local recording, not the Twitch one. So, yeah, that's the thing. Anyway, that's it for now. Thank you for sticking with me through all of this. I hope to see you next time. Snackis.